In this video, we are solving assignment problem. Before solving the problem, first we understand what is assignment problem. And this is general form of assignment problem. And this P1, P2 and so on, Pn represent persons. And this J1, J2 and so on, Jn represents jobs. And inside values like T11, T12 and so on till Tmn, it represents the time taken by the persons to perform these jobs. Assignment problem is, that is, our aim is to decide which job has to be assigned to which person so that the total time to perform all these jobs is minimum. Okay. Next one is types of assignment problem. First one, balanced assignment, and second one is unbalanced assignment. Balanced assignment means number of rows equal to number of columns. If it is not equal, then it is called unbalanced assignment problem. Next one is steps for solving assignment problem. This is basic 3 steps, that is row reduction, column reduction, and third one is assigning and finding the optimal solution. And these 3 are the steps for solving assignment problem. Now we are solving assignment problem by using Hungarian method. And here we have an example. First one is, find the optimal solution for the assignment problem with the following cost matrix. So cost matrix is given, and here A, B, C, D, and that is that represents salesman, and another one is area, that is W, X, Y, Z. So we have 4 salesmen and 4 areas. We have to find cost value. So first we have to check whether it is balanced or unbalanced problem. First we have to calculate number of rows. How many rows we have? 4 rows, right? A, B and C, D. And how many columns we have? 4 columns, W, X, Y, Z. So 4 rows and we have 4 columns. So both are equal. Therefore it is balanced assignment problem. Next we have to solve by using row reduction. That is step 1. Row reduction means we have to select minimum value in each row and subtract it from the rest of the elements of that same row. Okay. So first, in that first row, which is minimum 8 is the minimum value, and in the second row 6, and in the third row 12 is the minimum, and in the last row 10 is the minimum value. Okay. Using the minimum value, we have to subtract the elements in the same row. So first 8 is the minimum in the first row. Now we have to subtract 11 minus 8 and 17 minus 8, 8 minus 8 and 16 minus 8. So first one is 11 minus 8, that is 3, and 17 minus 8, 9, 8 minus 8, that is 0, and 16 minus 8, that is 8. Next move on to the second row. Minimum is 6. So 9 minus 6, 3, 7 minus 6, 1, 12 minus 6, 6, 6 minus 6, 0. And in the third row, minimum is 12. So 13 minus 12, that is 1, 16 minus 12, 4, 15 minus 12, 3, 12 minus 12, 0. And in the last row, minimum is 10. So 14 minus 10, 4, 10 minus 10, 0, 12 minus 10, 11 minus 10. Now write the values A, B, C, D. These are all salesmen, and this is W, X, Y, Z, and this is area. So after this we have to move on to step 2, that is column reduction. Column reduction means we have to select minimum value in each column and you have to subtract it from the elements of that same column. Okay. So again, I'm going to write the matrix A, B and C, D. So what is the minimum value in the first column? First column minimum is 1. So subtract it. 3 minus 1, 3 minus 1 again 2, 1 minus 1 0, 4 minus 1, that is 3. and in the second column minimum is 0. So if you subtract, you will get the same values 9, 1, 4, 0. And in the third column also we have 0, in the last column also we have 0. So if you subtract, you will get the same values 0, 6, 3, 2, 8, 0, 0, 1. After this column reduction, you have to do an assignment and find the optimal solution. Okay. So assignment is, first in the first row we have 0. So I'm going to assign this. If you assign the 0, corresponding column and corresponding row will get cancelled. Okay. Next we have to move on to the second row, and we have 1 0 here. So I am going to assign this 0. If I assign the 0, this corresponding row and column will get cancelled. This 0 is eliminated, okay, because I am cancelling this column. Now you are not supposed to take this 0 because it is already deleted. Next, move on to the third row. I have 0 here. So I am going to assign this. If I assign this, this corresponding row and column will get cancelled. And at the last row, I have 1 0. So I am going to assign this. After the assignment, you have to check whether all the rows have assignment. So in the first row, I have assignment. In the second row also I have an assignment. In the third row also assignment. And in the last row also we have an assignment. Similarly, you have to check in the column wise. See, in the first W column we have an assignment, X column, and here we have Y column, Z column. Now you have to find the optimal solution. Okay. So for finding optimal solution, we have to consider the main matrix. Okay, that is given in the problem. So optimal solution is this is salesman and this is area. So for the salesman A, we are assigning, here we have an assignment, right? So we are assigning Y. So Y area. So for salesman A, we are assigning Y area. Next, for salesman B, we are assigning Z area because here we have an assignment. So salesman B, we are assigning Z area, and salesman C, we are assigning, see here we have 0, that is W. So W area, and D, we have X area. So we are assigning each salesman to each area. So now we have to find the cost value to perform these jobs. So that you have to consider in the main table. So A to Y, what is the value A to Y in the main matrix? That is 8. So that is 8. And B to Z, B to Z is last value, that is 6. And C to W, C to W is this value 13, right? So 13. And D to X, D to X, that is 10. So write D to X value is 10. Now add all the 4 values, you will get 37. So this is the assignment cost value. Thank you.